Okay, two more problems. These two are going to give us a little more practice with problems where we don't necessarily get a special angle for our solutions. So more practice using the inverse function notation. In this first one, notice this is quadratic in tangent of x. So we can factor this. We'll have tangent x in the first two spots. And then factors of -8 that add up to -2 are -4 and +2. Set that equal to 0. So we get tangent of x equals 4, or tangent of x equals -2. And tangent has a range of all real numbers, so these both have solutions. So here's where we really need to be careful about how we write our answers. So we want to write the answers exactly. So let's think about a unit circle, and where tangent is positive, of course, would be in quadrants 1 and 3. So our quadrant 1 solution can just be represented by tangent inverse of 4. Okay, that's our quadrant 1. So wherever that is. In fact, I thought I had my calculator. Here it is. So make sure you're in radians, but if you do tangent inverse of 4, it's about 1.32. So that would be, remember that pi over 2 is about 1.57, so it's somewhere, here maybe, just estimating. And this other solution over here would be pi units away, so we could just add pi to that. That would be our quadrant 3 solution. Okay, so those come from there. For these solutions, of course, we're going to have one here and one here with the same size reference angle, so that's kind of how I decided where to draw those, right? So x equals, the problem with the tangent inverse notation is, remember, tangent inverse of x, not this x, different x, comes always, not equals, but because it can't equals negative pi over 2, but it's always between negative pi over 2 and pi over 2. So when you write x equals tangent inverse of -2, that is not in 0 to 2 pi. Remember, for this example, we want solutions in 0 to 2 pi. You plug that in, you should believe me, but if you don't, put it in your calculator. It's a negative number, right? It's in quadrant 4, but it's negative. So this is tangent, this negative number here is tangent inverse of -2. It's approximately -1.107. Oops, let me move that over. All right, so we want to be able to represent this exactly. Well, that's an easy fix. All we need to do is add 2 pi. If we add 2 pi, then we have 5.176 approximately, right? And that is between 3 pi over 2 and 2 pi. Well, we still need this solution. Well, if you go back to this number, tangent inverse of -2, just add pi and you'll get that solution in quadrant 2. So this one is in quadrant 4. This one is in quadrant 2. So we actually have all 4 of these here, one in each quadrant. Okay, and again, that's because we got all like a positive and a negative, so we're gonna have to get a solution in every quadrant. All right, let's do the last one. H, got cosine x equals -0.25. Okay, so that's in the range of cosine. There's nothing to solve here, it's just cosine, nothing to isolate. Cosine x is already isolated is what I meant. Still something to solve for. We need to solve for x. So again, tricky part here. We want the solutions in the second and third quadrant. And when you use the cosine inverse notation, cosine inverse at x is between 0 and pi, right? So when you write x equals cosine inverse of 0.25, you're only getting this solution. We need one here as well, right? The corresponding point in quadrant 3. So notice, again, you can use your calculator to get a feel for how big these numbers are. It's about 1.318. I also kind of just, whoops, I was like, wait a minute, that should be bigger than 1.57. That's because I put a positive in there, not a negative. This is in quadrant 1. Let me start over. Negative 0.25. Now it'll be bigger than 1.57. Okay, so 1.823 about. But I also remember cosine is the x coordinate, so it's going to be like a fourth of the way to -1. That's another way to look at it. Okay, so 1.823, it's just estimated, it's about right here. So we need to find how long this arc is, right? Or if you will, how big this angle is. Well, again, you can use this reference angle here. This will be this angle, or this number, these are the same size, pi minus cosine inverse of negative 0.25. So that's what we want to add to pi. This whole thing here, I'll use a different color, will be pi plus this reference angle, theta sub r, we'll just call it that, pi minus cosine inverse of negative 0.25. So, or x is, and of course this is 2 pi. So this is similar to the one we did in the example 1.25. So there's our two solutions. Okay, maybe, so I did 2 with cosine. What if I just change this, we'll call this example I, change this to sine x, negative 0.25. So sine is negative in quadrants 2, or 3 and 4, excuse me. Draw my unit circle again. So this would be, so sine is negative 1/4, so here and here approximately. So when I write x is sine inverse of negative 0.25, that's this solution, but it's giving me this as a negative number. So I need to add 2 pi to that to get in 0 to 2 pi. I guess I'll leave that there. Okay, so this is in quadrant 4. Okay, so see what look at the calculator. Sine inverse of negative 0.25. See, that's negative because sine inverse at x, or arc sine, is between pi over 2 and negative pi over 2, right? So you need to add 2 pi. Now you've got this length, which is about 6.03. This is exact, though. We want the exact. This is approximate. That's not the answer we actually want, but it's just to help you interpret the numbers, all right? So we got this solution. So now we need this one, and this will be pi plus this length here. The easiest way to get this length is to use this reference angle, but of course this this number is negative, right? So there's a couple things you could do. You could use absolute value. Okay, I want to make that a positive number. Then I've got the right length I'm adding. Or I could say x is pi plus, well, why don't I just use positive 0.25? Then that's the same, this angle here, which is what I want to add. These are definitely tricky, aren't they? They're not easy problems. So you need to think about these for a while to make sure you understand them. And let me know if you have any questions.